For any exam-related queries, call us at +1 678 648 4277. You can mail us at info@livexamhelper.com or reach us at https://www.livexamhelper.com. Electrochemistry Exam Help. Figure 1. A current sheet at x equals 0 generates a magnetic field for 0x less than d between two infinite magnetic permeability regions for x0 and x greater than d. A current sheet Re K0E minus JKZIY is placed on the x equals 0 surface of a material with infinite magnetic permeability, infinity, for x less than 0. Another infinite magnetic permeability material. Problem 1. Permeability, infinity, for x less than 0. Another infinite magnetic permeability material extends from d less than x infinity. Free space with magnetic permeability 0 extends over the region 0x less than d. The magnetic field, Hx, magnetic scalar potential, chi, relations for the planar layer below. Figure 2, planar layer used to determine general magnetic field/magnetic scalar potential relationships. For variables of the form. livexamhelper.com. Where there is no magnetic field dependence on y. A question: what are the boundary conditions on the magnetic field at the x equals 0 plus and x equals d minus surfaces? What are the values of the magnetic scalar potential chi, x equals 0 plus, and x equals d minus? Solution. B question: what are the complex amplitudes of the magnetic field H, x, z, at x equals 0 plus and at x equals d minus? Solution. livexamhelper.com. C question: what is the magnetic force per unit area, on a wavelength 2 pi/k, f on the infinite magnetic permeability layer that extends d less than x infinity? Solution. I. Put Maxwell stress tensor surfaces at x equals d minus at coordinate y and y plus 2 pi/k to extend to x equals plus infinity. livexamhelper.com. 2. Alternate surface at x equals 0 plus extending to x equals plus infinity. livexamhelper.com. Figure 3. A perfectly conducting incompressible liquid partially fills the gap between parallel plate electronics stressed by voltage V0. A perfectly conducting incompressible liquid, sigma infinity, with mass density ρ partially fills the gap between parallel plate electrodes stressed by voltage V0. The applied voltage lifts the fluid interface between the parallel plate electrodes by a height psi where psi s. The upper electrode in free space is at z equals s. When the applied voltage is 0, the fluid interface is located at z equals 0. The region outside the liquid is free space with permittivity 0, mass density of 0, ρ equals 0, and atmospheric pressure P0. The gravitational acceleration is g equals minus giz and surface tension effects are negligible. A question: what is the electric field for psi z less than s between the upper electrode at z equals s and the perfectly conducting fluid interface at z equals psi? Solution. B question: what is the fluid pressure P, psi minus, just below the interface at z equals psi minus? Solution. livexamhelper.com. C question: find an expression that relates liquid rise psi s, to voltage V0 and other given parameters. Solution: applying Bernoulli's law at z equals psi and z equals 0 interfaces within the perfectly conducting fluid where. D question: at what voltage is psi equals 2? Solution. livexamhelper.com. Figure 4. An inviscid incompressible z-directed uniform flow from infinity is incident on a sphere of radius r.an. Inviscid incompressible liquid with mass density ρ has uniform irrotational flow, times nu equals 0. The flow at R equals infinity is uniform and z-directed. Nu equals V0 I Z equals V0 I R cos theta minus I theta sin theta. The flow is incident on a solid sphere of radius r. The inviscid liquid can flow along the sphere so that nu theta, r equals r plus, equals 0 but cannot penetrate the surface so that nu r equals r plus, equals 0. Because the irrotational flow has times nu equals 0, a velocity scalar potential phi can be defined, nu equals minus phi. Because the fluid is also incompressible. Depend on angle phi. The flow does not vary with time and gravity effects are negligible. Question: what are the boundary conditions on the velocity scalar potential at r equals r plus and at r equals infinity? Solution: liveexamhelper.com. B question: solve for the velocity scalar potential phi r theta. Solution: C question: solve for the velocity field nu r theta for r greater than r. Solution. D question: what is the magnitude of the velocity nu r theta? Solution. liveexamhelper.com. E question: if the pressure at r equals r plus and theta equals 0 is P0, what is the pressure at r equals r plus theta equals pi/2? Solution. F question: what is the equation for the velocity streamlines? Solution. liveexamhelper.com. G question: for the velocity streamline that passes through the point x equals 0, y equals y0, z equals 0. Equivalent to r equals y0, theta equals pi2, phi equals pi2. For what value of y does the streamline pass through when x equals 0 and z equals minus infinity? Equivalent to r equals infinity, theta equals pi, phi equals pi2. Find y when y0 equals r and when y0 equals 2r. Solution. liveexamhelper.com.